that's governing it is present in this wallet or in this contract on the Ethereum blockchain, and anyone can modify it by calling the store or the increment function. The store function actually sets or updates the value, and the increment function basically increments the value of the current counter and increases it by 1. So now this is a contract that's deployed on the blockchain, and anyone can call the increment method or the store method to increase the value of this number. So this is governed by the people, and this can be retrieved by anyone as well, just to see what the current value is. So Ethereum basically lets developers deploy code on the network, and also lets people store data on the network. The code is as you see here, and the data is what you see on line 11, which is a number variable. So this is how Ethereum tries to let anyone deploy any protocol that they want on top of the Ethereum blockchain, and hence the utility of the blockchain increases much more. The second problem that we discussed was proof of work was generally a little slow and wasteful, and Ethereum tries to solve that by using something called proof of stake, which we discussed in the last video. Ethereum has not yet moved to proof of stake, and hence the transactions per second on it are still pretty low. But they claim that once they add proof of stake, ZK rollups, sharding, and a bunch of other optimizations to it, the transactions per second could go as high as 100,000 transactions per second. But that's still far away until the Ethereum V2 is released. So now let's try to dive into a new blockchain called Solana. Solana uses proof of stake as its consensus algorithm, but it has a few other optimizations to it, which makes it really, really fast. One of the biggest problems in distributed computing is maintaining a distributed clock. There are hundreds of nodes, each submitting transactions, and it becomes very hard and slow to synchronize these transactions across so many machines. The basic idea is that proving that an event happened at some point in time is hard and slow in a distributed world. If there are hundreds of nodes in a network, they'll take some time and a lot of internal communication to reach consensus around when an event happened. Solana solves this by introducing the concept of time to the blockchain by using something called as proof of history. The idea behind proof of history is that a validator or a node maintains a hash and keeps rehashing this hash as time goes by. Since every future hash needs access to the existing hash, this process can only be run on a single core. As validators receive a transaction, they add this transaction to the current hash before they go on to compute the next one. What this does is that when this validator submits a block to the other nodes for validating, it can prove the order of events and transactions by the proof of history ledger that it's maintaining. The other nodes on this network can validate this ledger on multiple cores by dividing the ledger into parts and validating each part on a different node. Hence, generating the proof of history sequence can only happen on a single core, thus consuming time and ensuring the validity of the event sequences, but it can be validated parallelly so that other nodes don't have to spend as much time to validate this sequence. Solana also lets you deploy smart contracts on the blockchain and hence tries to solve the first problem that we discussed as well. So anyone can deploy any use case that they want on top of the Solana blockchain. And thanks to proof of stake, proof of history, and a bunch of other moving parts that we're not discussing in this video, but you can find the link to them in the description, the Solana blockchain is really fast. And so if you're thinking of deploying more use cases that require high transactions per second, for example, building your own Facebook on top of the Solana blockchain, you can do that because the network is unnoticeably fast. And hence, any smart contract that is deployed there, any transaction done on top of that smart contract will usually not take more than a few seconds. And from all the videos from here, we'll try to understand how you can deploy your own smart contracts, but also interact with the smart contracts that already exist on the Solana blockchain. So I hope to see you in the next one.
So here we got to know basic understanding about how Ethereum and Solana blockchain differs. Basically, Solana is using a concept, something called as proof of history, where they are keeping track of all the transactions that are happening, and they are hashing it like the transaction hash of the they hash the hash of the transactions. Okay, so by that way they are maintaining a kind of history about which transactions happened after which one, and that is how they are coming through like consensus algorithm and validating the new blocks. One more thing that is very different in Solana is that the accounts model of Solana. In Ethereum, if you guys are having some knowledge about Ethereum, if you have done some coding in Solidity, by now you must have known that if you create any variable or create any mapping, so all those things, the storage, all these things are stored in the smart contract itself. Smart contract has the property or the ability to store things. They have got their own memory. Okay, but in Solana, first of all, the smart contracts are not called smart contracts. Those are called just programs. So in Solana, if you write some program, the program itself might not have the ability to store the variables. It does not have the capacity to store things, but it creates some another account in which they store the variables. Okay, so now we will be looking at it how those things are done. We will go through a blog where it has explained about the working accounts model of Solana. Okay, and we will just everyone will go through it, go through the blog, read it, and understand what it talks about. So after this video, anyone has any doubt or something, anyone wants to share anything, can just you can share it. By that time, I'll just open that blog.
Do we get to do any development now on today on Solana, like on smart contracts on Solana today?
Yeah, we will do that. We will do that. But before we dive right into programming on Solana, it's important to understand how things are working.
Yeah, that hashing part, right, where it creates the hashing history, the proof of history. So how does it
Uh-huh.
create that hash, like from the previous hash? Like, what does it vary? How it will tell that?
Okay, so even I don't have clear understanding of that, because that is what Solana implements, and we don't use it generally. Like because when we are writing programs, we generally don't bother about how Solana is doing that, because that is on Solana's part. So even I don't have clear understanding of that.
Yeah. Okay.
Yeah. So we'll just go through this accounts model in Solana. So the basic idea of this Rust study session is where we go through, we learn we learn along with each other. Okay, so here I or you, like anyone, we all read it together, read the blogs together, or code it together, and learn it on the go during the session itself. Okay,
Yeah. Could you share this link of this
so
code?
what it is saying that, yeah, let's share the link here, chat. So what it is saying that most new developers find it difficult to get started with building on Solana because they find the programming model unintuitive. However, it is far from unintuitive once you understand it from the first principles. My goal at the end of this article is to get you to the aha moment I had when I finally made sense of it. Before we dive into the accounts model and understand how things work in Solana, let's work with something very even simpler. So this is a very basic Rust program. So they have defined a struct, okay, named GM counter, where they are counting the number of GMs. Okay, they have defined a variable called count inside struct, which is of type unsigned 64, and then they have this main function with a variable called counter of which is of type GM counter, and whose count has been initialized to 0. And every time this function is called, the counts value is incremented by 1, and then they are trying to print the size of the count. Okay, so what it is saying that Rust will allocate 8 bytes of memory on the stack and return a reference to its address. Okay, this one. Every time a program has to store something in its main memory, the runtime takes an exact size requirement. It finds a location and returns its address to you. So whenever this struct is being defined, it allocates an 8 bytes of memory and returns the address of the struct. And what is saying that it, uh, every time your program has to store something in its main memory, the runtime takes the exact size requirement and finds a location to store this struct, and then it returns the address so that we can manipulate the contents of address the way we want. So this works great as long as the program is running. If we were to restart or run it again, the state of the program gets reset, and this is quite like important. it was very practical, right? So whenever we'll run this program again, the count value will restart from 0, right? So yeah, so that is what they're saying. So in order to prevent this, we can replicate the content of the memory and store it to disk and restore the state upon invocation. So what they're saying that we don't do is we will just store the value of this count in a disk, like in a file. Okay. So what they're saying, yeah, what they're doing here, they are just storing the value of that count in a file called simple counter, and then they are reading it from there and stuff like that. And what they're doing, see, load from file system if the file exists, otherwise just create a new counter. Okay. So yeah, so here what they're saying that they are just checking if it's true. They are creating the they are restoring from the file here, and if it's false, it is creating a new struct variable, uh, gm counter, like initializing it to 0. And then they have defined a function gm where they are incrementing the value of count. Okay, and then here they are incrementing the value of count, and then they're printing the value of counter, and then they are again writing it to the file. So after incrementing it, they are writing to the file and storing it back again. Now whenever we'll run this program again, the count will start from the value that was stored in the disk. So this way we are kind of storing the state of the count. So what he's saying that our setup works well when we have to do is support one user. So this is cool enough for one user. For multiple users, perhaps we could use a hash map to keep track of all the users and their GMs, right? So this is like if I am coming and running this program, the count value will increase. If someone from you will come and run this program, that count value will only increase, right? So it is not creating as of now a mapping like who is incrementing the count. Now what they're saying that now we will keep a hash map to store who came and incremented the count. Okay, so that the value of count increments respect to that user itself. So here yeah, so here they are using a hash map to store the user ID and the gm counter to store for every user ID the count. Okay, and for yeah, so for here dummy, so they have made some dummy user IDs, like 10 user IDs over here, and they are inserting the ID and the value of the counter and incrementing it. So we could do the same load from this as before. However, we would be loading all users and the counters into the application memory. This can be problematic for the following reasons. Now, what they're saying that now we are storing the value for each user ID and their state of the count. But if we run this program again, the count for each user might reset, right? So what they're saying that now if we try to store this state in the file system, in the disk size will, like a lot of this size will be occupied. So what they're saying, we could do the same load from this as before. However, we would be loading all users and the counters into application memory. This can be problematic for the following reasons. Every invocation will load the entirety of application state into memory. Okay, and frequency of access may be different for different users, ensuring thread safety and preventing concurrency bugs. So these are the problems that may occur if we try to save the states in the file system in the disk. So what they're saying, what can we do to allow concurrent access while maintaining persistence? Perhaps instead of snapshotting the entire application state, we should isolate the snapshots to a user and the associated data. Okay, now what they're saying that instead of maintaining a whole structure or a whole hash table of the user ID to the accounts mapping, we could just isolate those users into different accounts, where for each user account will be maintained, and in that account the value of that account will be stored. Is everyone getting it?
Yeah.
Yes, Shweta, but like
Yeah,
if
it's very.
two persons run at same time, would the count from the other account will be updated to this other account, or it will be independent of each account?
Sorry.
Uh, Say you are saying now there are suppose some n accounts, and each account is independent. Like when we run this code first time from one account, say the counter value is increased, and some other guy ran the code from his account. Now, would it be using the that updated value, or the just it will update it to the count as one cell?
Yeah, here every person will have their own account, and in that account he is or like their own account variable will be there. Okay, for example, if you are running this program, then your account will be created, and inside your account there will be one count variable and it will be incremented. Okay, and next, if say for example Ayush is running the same program, a separate account will be created for Ayush, and inside that account his own count variable will be there. Okay,
Yeah.
so
So now
everything,
these counts are independent of each users, right?
yeah, these accounts will be independent of each user. So whenever you will be calling it, only your variable will be getting affected, not anyone else's.
Yeah, got it.
So, the
And
scenario that you mentioned, which I feel is likely to happen, is if one particular account data is being shared by multiple people, like the same state will be, say, can be affected by multiple people. For example, if we build a game, right, and we are keeping a track of how many participants are joining the game, right? Now, that number is going to be the same for everybody who is a part of the game, right? If there are four people who have joined the game, then the counter should always reflect four. If there are five people who have joined the game, the counter should always reflect five. So, in the case where I am understanding your question in this way, that if what if two people are trying to join the game at the same time, how would the counter value affect? I don't know if this is something similar. This is an analogy to what you are thinking, or
yes, Lakshmi. So you mean to say that each accounts, like each person, what I understand is when each person runs this program, it will create an account for themselves. Like not one account is not being used by so many users. Each person has his individual accounts.
no, that may not be the case for all the programs. See, it depends on the program logic. For example, the program that we are going to look at today, the calculator program, it won't create one account for each person. There's just one calculator, and there is one
Okay.
account for the calculator. So think of it as there is a calculator. I don't have a calculator, but there is a calculator that this is a single calculator that everybody is going to use. So if I come and use this calculator and I say that I want to do addition and I put in two numbers, the result is going to be the addition, whatever is the final result from the addition. And this number on the calculator will stay till the next person comes and uses the calculator. They may do subtraction, they may do multiplication. So in this case, there's only going to be one account.
But yeah,
This,
that's what I'm account is. In
yeah,
this
so
case,
this,
we are having only one account, but
yeah,
in other programs might have multiple users for that
yeah.
same
So
account, and like
exactly. In the case where, for example, we are playing games, right? In the games, what happens generally is that everybody will have their own state, right? I will have some points that I have collected. You will have some points that you have collected. Shweta will have some points she has collected. So in that case, implicitly, the program creates something called program derived accounts. And they will, what these accounts will do is each account will have the data of that particular user. So this is something different about the Solana ecosystem that we have to understand in order to actually look into the contracts. We are
Yeah, so
also,
actually the main so the main intention behind telling like every user will be having different account, and different account will be storing the count variable separately independent of each other, because from here I was trying to establish an analogy with the Solana program.
mm.
Okay, so we'll just see. Yeah, So what we have done here is to take out the hash function, use it to dump the counter file instead of a hash map. Now that the user data is partitioned and isolated to a single file, we could invoke the GM function against a particular user ID without affecting the global state. A nice benefit of this is that the runtime can access multiple user IDs in parallel. What we have essentially done here is to externalize the state and decouple it from our code. Okay, so are you getting it? So what they're saying the same thing, that they have just isolated all the user IDs, their accounts, into isolated files. Now if I am accessing this program, and if you are also accessing that program parallelly, then our IDs, sorry, our variables will not get affected and the program will run smoothly. So if a client wants to query the number of GMs a user has received, they can simply look it up from the account file we just created for the user. Okay. However, the data is saved as raw bytes. In order to make sense of it, we would need to know the structure of the data before it was serialized. Okay, so this is something that Solana uses, something called serialization and deserialization, because the data is stored in the form of bytes in the program, okay, in the like blockchain. So when we retrieve data from there, so we need to serialize it so that we can read it from there. And if we are storing data into the blockchain, we need to deserialize it to store it in the blockchain. So
Yeah.
it is expensive to maintain a global state durably in memory, especially if the state can grow quickly. We could persist the global state in a single file. However, this doesn't scale for concurrent access. We isolate the state per user and persist them to the disk. The file names are named deterministically so that clients can look them up using a one-way hash function. This decoupling of state and code is one of Solana's core features, and how we create smart contracts or programs in Solana is dictated by its accounts model. Okay, so so here he has like in the next blog he has explained more about the accounts model, like how this analogy is established. So basically I'm telling you right now is that in the same way, here he has tried using the analogy of users accounts being created in Solana. What happens when we deploy a smart contract or say program? Each program For each program, a separate account gets created. Just replace the users with programs. Okay. So for every program, separate account gets created where the data gets stored. Getting it?
Yeah, I think it's a little bit heavy to begin
Yeah.
with, but this concept of accounts will keep coming up throughout as we keep going with the smart contracts and stuff. So we have to slowly break it down. And if you guys also get to read some other articles, yeah, this is one more that
Yeah.
I've posted. So if you also come across other articles that you find are much more simplified and are, or any YouTube videos, explainer videos that you find, please do share with the group. So I think it will be helpful.
Yeah. So go through these articles, and you will get to learn a lot about accounts model. So we have tried to cover it like in a very basic thing, like at a very higher level, so you can deep dive into the accounts model.
I think
Yeah.
the big difference here, on what we work on Ethereum, right? It's like the data gets stored on chain via the contracts, right? For
Right.
example, let's say you have an NFT, you create an NFT out of using ERC 721, that
Right.
your data stores on chain.
Right.
But as far as we have seen on Solana, right? So let's say I have my Solana program, and my Solana program has an associated account, so that get mapped to a user. So my data resides on that particular account, right?
Yeah,
Yeah. So
yeah,
this
kind of.
mapping to user that you are talking about, right? This is not necessary.
Yeah,
See, because it's not required in all the programs that a user needs to be mapped to the program. I think this is also one of the primary differences coming in from Ethereum, that a user, actually even in the Ethereum ecosystem, right, a user is only mapped to a smart contract. What the smart contract stores and the state changes associated with the smart contract are actually mapped with the unique address that is generated for the smart contract. So in this case, if we think of it, it is more like a user deploys a program, and
Okay.
the deployer or the signer,
Mhm.
once they deploy a program, they create a kind of account.
Okay. Okay.
If within that, this program can now create multiple accounts to
Okay.
perform whatever actions that it wants, which are called program derived accounts.
Mhm.
And these different accounts could be mapped to this main user who deployed the contract, or could be mapped to other users, or could be just used for storage by the contract.
Okay. Okay. So basically, as a user, that let's say I could use SPL token library to create tokens. So every time I create a token, right? Uh, so I have the capability to create multiple accounts, right? As a user, I can create multiple accounts.
Okay, I'll just explain one thing over here, that in Ethereum, in Solidity, when we write a smart contract, for example, we have declared a mapping or an array or anything or any struct. Okay, so if we know the contracts and we have deployed the contract, okay, smart contract. Now, if we know the smart contract's address, we will be able to fetch that. Maybe if the variables are public, we will be able to fetch those variables from there, right?
Yes.
But
Yes.
in Solana, what happens? For example, you have written a Solana program and you have deployed it.
Mhm.
Okay. And you have got a program ID, which is basically equal to that program's
Second.
address. Okay.
Yeah.
So you can't just use that program ID to fetch variables from that program, because in fact, because that program is stateless. In Solana, programs are stateless.
State.
Okay,
Yeah.
they don't have the capacity to store things, okay,
Okay.
in memory. So what in turn they do, they create accounts, uh,
Mhm.
where they store the memory, so where they store the variables. Okay,
Okay.
so we'll see the program where we'll be saying that program ID is not enough, we use something called accounts, and we use that account's address to fetch variables from there.
Okay. Okay.
Okay.
So basically, this account keeps track of the state, right?
Yes, yes,
Okay.
yes.
Okay.
Hmm.
And one more thing, like I was having trouble in understanding PDA. Could you please explain how this PDA is working?
Which
Because
one?
I'm
Program derived
yeah,
account.
program derived address. Yeah.
Yeah, we are also
Okay.
not 100% sure on that, but I think you will understand better when we go through the contract,
Okay. Okay.
like how the accounts are actually getting created and being derived.
Okay.
Uh,
Yeah.
yeah, and also this is a good article actually that you can read, the Solidity to Solana kind of comparison and how the account system is working. This one is pretty good.
And one more main important difference, right? We have a concept called rent here, right? Which is not in Ethereum.
Which one?
Rent. Sorry, the concept renting, rent.
Rent.
Yeah,
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 yeah, yeah. Yeah, we need to pay rent to store data in
accounts have
Solana.
to pay rent. Yeah, yeah.
Yeah, and if you fail to, if the time lapses or if you fail to pay the rent, then that account gets, I guess they just remove that account or something
Yeah,
like
so
that.
I think data is purged from there. Yeah.
Yeah, yeah.
I think it's the rent which we are paying. I hope you have used it. Using Solana CLA, we can calculate our rent. For example, if I want to calculate the rent for my data of 8 bytes, which I'm going to store on chain, I can get something called rent per year, rent per epoch, rent exempt and all. So
Yeah.
which is like for storing my data on chain, that I'm paying a certain amount of SOL,
Right, right.
right?
Yeah, yeah. I'm paying for storage basically.
Okay.
Hmm.
That's
And
the concept.
And have you tried it? Like I read it somewhere that, you know, when you pay rent on Solana, right? Basically you're paying to store the data. I have read somewhere that if you want to get that Solana back, when you close your account, that you will be getting your rent back, whatever the amount you have paid back. Have you come across something or anything?
No, I
No,
have not
even
tried
I'm
that.
not. Yeah.
But I think
I, uh, sorry to interrupt. Yeah, I think I can answer that. Hi, Sheikh here.
Yeah, hi. We were just going through your blog, so
Yeah, Prakash was telling me about this, so I decided to just
yeah.
drop by. Anyway, so Solana has this concept of rent where you, so if you look at the next article under the hood, right? So there is one, this is the intuition. There is one more article about how the accounts model works under the hood. There it talks about how, so every account has some metadata associated with it, which also, every time you create an account, you also have to fund it with the minimum amount of rent. That rent is based on how much you intend to store there. So after every epoch, the runtime will start deducting the balance from your this lampposts that you see, right? From that, your rent will get deducted. In order to prevent this, because you never know, you always are in this place where you have to keep this wallet topped up, right? So if it goes down to zero, your account gets garbage collected and the program won't work. In order to prevent that, Solana runtime has a mechanism where you can fund 2 years worth of rent at one time and just keep it in your account. So if it is, so that way it becomes rent exempt. And this is what you can recover when you close your account. From the economics perspective, this makes sense because for every interaction, you are able to take some SOL out of circulating supply and keep it locked, right? This is basically a weird way to do staking, except that you get to use the system, but you're not getting any rewards out of it. So economically, it makes sense because every interaction also locks up the lampposts in an account, right? And that's what you will, for example, you no longer need that account. You can close it and you can withdraw all the lampposts back.
Oh, that's interesting. So the heavier my data structures are going to be, the more I have to pay initially just to cover that 2 years.
Exactly.
Oh, interesting.
And Abhishek, by the mean of epoch, so what you're saying basically, let's say I have a set of instruction which I'm about to, implement on chain. Let's say I have 4 different instructions, right? So when I initiate my account, right, I'm not going to use all 4 instructions. I'm just going to use any one of those instructions. In that case, I'll be charged with 1 epoch. Is that what you're saying, Abhishek?
No. The epoch here is, so epoch represents the time, right? The whole Solana works on this concept of arrow of time, where every passing time, that is an epoch. So 1 epoch is like certain number of time slots.
Okay.
So after, you can think of it as like as a timer. For example, let's say it's a timer which runs for an arbitrary amount of time, say 3000 seconds. So every 3000 seconds, your account will get detected. That's the rent epoch.
Okay. So which is like I'm storing my data on chain for every epoch. Since my data resides on chain, I'm just paying a fraction amount of lamppost as a rent.
Exactly.
Okay. I wasn't.
And in order to prevent that from happening, you just pay it at one shot, right?
Okay.
You deposit all the rent that you would pay for 2 years at one shot, and you won't be charged anything after that. After you stop using it, you can get it back.
Okay, okay.
So, Abhishek, I have a question in this case. So, initially, when I deploy my program, for example, if it has got something to do with like the gaming ecosystem, the more people who join the game, or rather call certain functions in the contract, then the more accounts will be created for this particular game, right? And then there's like data being stored and stuff. So, if I want to pay that rent for 2 years, what is like the storage that it is keeping in mind in the beginning?
Yeah, so all of this boils, so this is how the accounts model work, right? Every interaction, every time user creates an account, the account is isolated to the user.
Right.
If you go back to the previous article, the intuition, it talks about how instead of what Ethereum does is it maintains a global hash map per contract,
Right.
right? So the opposite of that, here it is the opposite. Everything is isolated to one user. So whenever that user interacts, they will be the ones
Paying for it.
creating those accounts, and they will be the one paying for it. In order for you to understand this unit economics per interaction, right? What it boils down to is your data structure and how much amount of memory one single data structure will consume. And that's what you have to allocate.
Okay, got it. Yeah, that makes sense.
And Abhishek, one of the problems which I'm facing here in Solana is like when I write a simple program, let's assume a simple program, right? When I try to deploy it on chain, it is taking, it's like 3.5 sol to 4 sol just to deploy a simple program. Is this the process only for DevNet, or is this the actual process which is going to happen on the mainnet as well? We have not deployed it on mainnet. We have just, testing things around how it's
Yeah,
going.
so when your program also takes up space, right? So when you deploy it, when you generate it from Anchor, I'm assuming you used Anchor. What it does is it also, one Anchor by itself will create like larger program bundles. Along with that, it also pre-allocates space for your program in case it has to grow, right? Right now, the runtime Solana does not have the functionality to resize an account after it has been allocated. That's the reason why it is taking my first guess is you are using Anchor. The second one is because it is also over allocating the data so that in future, when you make additions, your program's complexity increases. You will need that space so that you can upload your program.
Okay. But this is going to be a default case, right?
Yeah, you can optimize this.
Okay.
But with Anchor, you don't have those cases, right? Like you have to deal with like directly deploy it using the Solana CLI to be able to optimize these things. But then again, you run into the problem of not having enough space to deploy new versions of your program or upgrading your program.
I get it.
All right,
Okay.
folks. If you have any
Okay.
questions regarding accounts, I think we should just run this like session today's maybe for basics, like for those who want to clarify. Because we have Abhishek, I think we should just like use his precious time wisely and maybe do the contract another session this week.
Yeah, I can take like a couple more questions. And if there's no more question, I'm happy to give the floor back to you guys. I was curious on what's happening, so I just wanted to drop that.
Yeah, so we actually just kickstarted like last week, where we just did like a Rust recap and did the installation and all that. So as we start going through the concepts and parallelly looking at contracts, we are not blocked by any of the installation and like running the code pieces. But basically, we are just getting started today, I think, in terms of understanding the Solana model and how programs actually function. So we decided to do the accounts first and then maybe do a basic program, but we only have 10 more minutes, so that's not going to be enough. Maybe we'll do another session this week for the program. But yeah, it would be really grateful if you could like, I mean, it would be awesome if you could just like join our Telegram group. We don't have that many questions, but I think when we get into the contracts part, maybe
Yeah,
we'll have a bunch of questions.
yeah, sure. I'm not that active on Telegram, but yeah, you can add me.
Are
I'm much.
you there on the super team DAO Discord group?
Yeah, yeah,
Okay, cool. So we have a Rust, um, Rust
Session channel
group
is
there.
there.
yeah,
Yeah, the
yeah,
sessions.
yeah. That's where I got this link from. So
Yeah.
Oh, cool. Okay. Yeah. So I think as the questions and all keep coming on Telegram, I'll just keep posting it here. And if you have some time, please do take a look.
yeah, awesome. Will do.
Okay.
Thank you so much. Yeah, I'll give the floor back to you all.
Thanks, Abhishek. So, Shweta, do you want to just set like the context in terms of like what we want to do next session?
Yeah.
Because I don't think, yeah.
Yeah, in the next session, what we'll do, we will try to build a calculator in the Rust program, so that, and we will be following this quest book quest, where they have shown how we can develop a calculator using Rust, so that it will give us an idea about how to, program on Rust, since we have completed the basics of Rust. Here we will be developing a full-fledged program with concepts from functions and structs and everything together. So that will be really good.
Yeah, and it will be really helpful if you could just complete the first 4 steps, which is just about setting up the environment. Like this was one of the reasons that I kept on enforcing that please set up the environment and come. So we will directly go into the programs because the programs themselves can be little heavy to understand even for beginners. I mean, even Shweta and I are slowly getting into Solana, so we are also fairly in the beginner stage. So it is a bit of like back and forth for us to understand the syntax and what this is signifying, etc. So we will spend more time on that, getting clarity on that instead of doing the setup. So if you can set up and come, then we'll spend the entire 1 hour on just the program. And I think this is a good place for us to start the calculator program. It's a small program with basic logic, and we'll do it using Anchor. So for those who have Windows, please ensure that you have your WSL set up and running, so you can use it seamlessly. And for those who have Linux or Mac OS as well, ensure that you're able to set up, install your basic stuff like Solana, Rust, Anchor, and all of these things, and come prepared. So that would be helpful. Maybe we can do another session this week, Sweta, so we can be on track. Let us know, folks, like what day would work for everyone, and we can just do another session this week. Probably we can do 40-45 minutes just to go through the program, and then we can close.
Yeah, sure. That will work for me.
Yeah, maybe we can take a consensus on Telegram group as well, but I'm most inclined to do it on Thursday because Fridays are like people want to go out and stuff, and we just did a session today, so maybe we want to take a break tomorrow and just like go through the existing concepts. Uh,
Sure.
we can do Thursday if same time, 6:30 to 7:15 or something. Yes.
Yeah, it sounds good to me.
Okay. then let's meet on Thursday and wrap up with this calculator program. So we have at least a foot in the door and have written one program. Apart from that, I just want to remind everyone that we have a lot of bounties that you can work on. We want writing bounties on how to deploy your first program to Solana. How does Rust, how does the Solana ecosystem work? Like things that you learned about, like the accounts model and all that. If you can just simplify that as much as possible. And So we have 5 writing bounties throughout the study group, and each of them are like anything between $200 to $500. So feel free to kind of just write whatever you have learned. Most importantly, in such a way that it's a learning process for you and maybe other beginners who are looking to get into the ecosystem. They also understand uh, like what is happening. So encourage everybody to write and submit your articles, and Sweta and I will definitely review, and we'll get back to you regarding the bounties. So you can take a look at the bounties on the Rust study sessions page that we have given, and you can just go through that. And most importantly, in the next upcoming weeks, we are you can send the link to the on the Telegram group, or in DM to us, to either Sweta or me, or you can just post it in the Telegram group saying, hey, this is my article for the bounty, and why don't you take a look and stuff. So it's pretty transparent, so I don't think you have to worry about it. And the aim of our Solana study group is to try and complete a couple of programs by week 8 in the next upcoming weeks. And we want to then go ahead and do larger coding bounties. So if you are able to deploy and run any 2 programs on the Solana blockchain, you don't have to worry about the front end as of now. We are only focusing on Rust and writing the contracts. So you can use the Anchor plugin as well. And couple of ideas, we already put it in the doc, but we would like you to pick your own ideas and maybe write 2 functioning contracts and deploy it. Whoever does that will be like 100% guaranteed for some bounty for sure. So that's what we are looking to achieve at the end of 8 weeks, that we're able to write our own logic and deploy it on the Solana blockchain, just from the contracts part. Doesn't have to connect with the front end and all that, right? Because that's what we want to focus on.
I sorry for chiming in. I also wanted to give an kind of an intro, plus I wanted to announce this as well. I am actually working on an extension which will support Anchor and Solana installments into VS Code. So I have created this extension which I want in this study session I'm going through with all of you. I want you all also help me testing this extension. I want to make it useful for the whole ecosystem. It will be better if it's useful for us initially. And yeah, there will be more bounties coming with respect to this extension uh, that I'll be contacting Janana and Shweta as well. So
I've
Nice.
already installed your extension. Have to just use it for calculator program.
I think so. There are some bugs with respect to I work on Mac OS, so extension works greatly on Mac OS. I really needed to test it with Linux people, people who are using in WSL, people who are using it in Linux. So I wanted to test this extension in both of these platforms. Plus, right now what's happening is there is no tool set or tool ecosystem inside Solana, where most of the developer tools are not there. There are some Soteria and those security audit CLIs which are there, but there are less supported tools and they are distributed everywhere. So we want to bring all the Solana development tools inside your VS Code so that it's easier for you every time you want to start coding in. Also, there will be a huge there will be huge bounties coming up because we have to solve for this problem where people are like getting discovered of these C-level attacks, which can happen with respect to unsafe math or unchecked accounts. So those things that we will be detecting errors inside the program on the same line. So there are things which are there are things which will be keep coming in this extension. I want to get all your feedback and implement those features so it's easier for you as well. And this extension empowers a lot of Solana developers. So yeah.
Nice. Thanks, Ayush, for joining us and showing us your product. And I'm pretty sure we all will be using your VS Code extension. Give you the feedbacks.
Great. I'll be
Yeah.
joining Rust sessions every time. I'm also learning Solana, so it's very great. Learning and
Awesome.
like,
Yeah,
doing
I
class
think
together.
anything that makes developers' lives easier, I'm definitely on for those products. So yeah, thanks Ayush for sharing that.
Yep.
All right, so then we can close the session for today and
Yeah.
meet.
And meet maybe day after tomorrow.
Yeah. Let's do that. Okay, all right. Thanks.
Yeah, okay, yeah. So if you want, if you have extra time, you can already go through these quests and come.
Yes.
Else you just set up the things like Anchor and Solana on your system and you can come and we'll do it together.
Yep.
Yeah.
Sure. Thank you, Shweta,
Okay.
and thank you, Jnana, for the session.
Yeah.
Thank
Thank you
you.
for your
Thank
time.
you so much for joining.
Yeah.
Bye-bye.
Bye.
Bye-bye. Thanks.
Bye.